Hey everybody, what you see on the screen, find the length of a line segment from one point to another. The top, I said don't use the formula. So fighting our urge to just have a formula and plug numbers in. Is there a better way? Let's talk about it. So what you see on the screen right there in blue, that is the formula for length of a line segment. Now, how that formula is derived, I'm hoping you have some background with. What I'm going to do is I'm going to talk about how to find the length of a line segment without referencing that formula. Concept-based, and then maybe that makes us a little faster to work with it. Okay, here we go. So if I was to ask you to find the length of that line segment as a concept, that means that if I was to put down a very quick sketch, left 2, up 5, maybe that's point A, and then going all the way over 6 and up to 10, maybe that's point B, and as a very crude sketch, we get something like that. Now, that blue formula, where it comes from, is really an application of Pythagorean Theorem. Any line segment can be viewed as the hypotenuse of a right triangle. So if we have some idea of how far apart are our x values, take a look on the screen right now, I would have to go from -2 all the way over to 6. That would be a horizontal side of 8 units. How far apart is point A and point B from my y coordinates? How far up would I go? Well, I would have to go from 5 up to 10, 5 units. That what you end up seeing then on that diagram is really just the application of if I was to call c squared equals a squared plus b squared, your very generic Pythagorean theorem. But if I was to instead say, well, I'm going to find the side length of AB because I know that I can take the root of the horizontal side squared plus the vertical side squared. That becomes a really quick way to come in on root 89, and there is your exact length. So my argument to you is going to be, think about that line segment as a hypotenuse, determine a horizontal side, a vertical side, who cares what order you want to do that in, and use Pythagorean theorem. So let's try one more. So I take a look at point C to point D. Now I'm going to include a sketch, but I'm going to do it at the end because I want this to be efficient for you. Is there a better way? So if we were to take a look at it then, we could say, well, I know I'm finding the length of the hypotenuse, CD, so it has to be the root of how far apart are my x coordinates? What's the length of my horizontal side? That's 5. So I got to square my 5. How far apart are my y coordinates? That's my vertical side. So to go from -7 all the way up to 2, I would have to go 9 units. That's going to end up getting me a 25 plus an 81. We then get root 106. And if you were to go through, you should be looking to, hey, can I factor that and see if that root 106 reduces? It doesn't, so we know we're good. There's my full solution in gold. You wouldn't have to show me anything else. And I would argue to you, that's a pretty efficient method to get there. What it also does is it eliminates silly calculation errors. Subtracting a negative when we plug into a formula. No, who cares? Think about how far apart are your x's, how far apart are your y's. What we want to do is just move away from having to draw a picture. And that's what the formula really does for most people, is it just says, I don't want to spend the time going through and constructing a picture for every single problem. So my formula becomes just an algebraic way, a way to calculate. But I think you can think about that process the same way. Look, how far apart are my x's? How far apart are my y's? Use Pythagorean theorem. Okay, I'm hoping that gives you maybe a different way to view finding the length of the line segment And I'm really hoping that it drives you away from having to memorize a formula. I think for most of us, Pythagorean theorem could be something that you already have in your back pocket. So you don't need to learn something new, a new formula, to be able to find those lengths. Okay, I hope that helps, and best of luck with your practice.